Okay. Oh God, I write that.
Okay, everyone, we're going to start in about a minute. Some people are still signing in.
Hey, how about me? We have 20 people online.
Okay, I think we can start. Okay, good afternoon, everybody joining us on this webinar. My name is Mike Velec, and joining me is Jean-Pierre Bissonnette. This is a pre-RTi3 webinar entitled Rock Your Talk, the Art of Delivering Scientific Presentations. And given that this is kind of the pre-conference webinar, you can also think of this as how not to bomb your oral presentation at RTi3. So like I said, my name is Mike Velec. I'm a radiation therapist and research fellow at Princess Margaret. And Jean-Pierre is a medical physicist at the same institution, as well as an associate professor in the Department of Radiation Oncology, University of Toronto. So as you probably know, why you're joining us today, you've gotten the learning objectives. In general, what we're hoping after this hour session, you guys will be able to identify audience learning styles and understand optimal delivery strategies when giving talks or teaching in general. We'll hope you understand components of clear and effective presentation visuals. And then ideally, you'll be able to apply these tools during your next oral scientific presentation, for example, at RTi3. So in general, what we're gonna do is Jean-Pierre is gonna talk first. He's gonna kind of give us some insight into teaching styles, some of the theory, and how the mind works. And then I'm going to jump in at the end. We're going to come back to me, and I'm going to give you some practical tips that you can apply during your next talk. If you have any questions, you can also, we have Sarah with us who's going to be moderating the chat. So if any burning questions, you can type them in and we'll address them in between the talks as well. Okay.
All right. So let's project. All right. So thanks, Mike, for the intro. So what I want to do in this part of the presentation is tell you why the tricks we'll be giving you throughout the presentation work. But as we start, I'll ask you guys to think a little bit about your best learning experience. Not best in terms of entertaining or I really liked what I saw or I had good chemistry with the teacher, but effective in the sense that you learned from the session as opposed to being entertained. Okay, so these are things that I want you to keep in mind through this presentation. So the objectives of my part is to help you recognize the rationale and theories for interactive presentations and why they work, motivate you to consider the tools and techniques that we'll be presenting to enhance learning and the effectiveness of your presentation, and again, share and demonstrate tips with you for future use. So healthcare is a complex subject. We all know that, but sometimes we fail to realize how complicated it is to integrate a new piece of knowledge into the way we run lives and how to transform one's attitudes, behaviors, and skills for application further down the road. We need to realize that our audience has a raw knowledge base and we already have sophisticated skills. So we need to figure out a way to get people interested in this new information that you're presenting and integrate that information in the way we work and to build a solid intuition and sound judgment on its use. Okay? However, we have to recognize that the format of a scientific presentation is also limited. We typically have anywhere between 7 and 12 minutes to convey a lot of information, and the format is typically that of a didactic lecture, sometimes with some pre-readings. And essentially, we were mimicking the way we were taught. If we like a professor's style, we try to do the same as they did. But mimicking is one thing, but doesn't necessarily tell us how we understand how humans learn. And this is what I want to focus on in this section of the talk. So why do I bother telling you about how humans learn? Well, I mean, maybe they'll help us to transform good presentation skills that come naturally to individuals to from an art to a science that can be taught and that the audience can actually emulate and become more effective presenters. Essentially, in education lingo, it's teach the teachers. So when we think about effective sessions, effective presentation, what have we learned? Okay? What cognitive psychology is telling us is that teaching and learning is not straightforward. It doesn't happen by magic that you do a presentation and at the end of the 7 or 8 minute presentation, magically you become highly skilled or highly expert in that knowledge. All of us need to process the new knowledge that's being presented and make it sense of what we already know. And a hint of how this thing happens is sometimes when we chat to people after we give a talk, some learners can make some bizarre errors. They completely misconstrue the meaning of what we said. And sometimes that leaves us wondering, did I do a good job? Or is it the way that humans learn that that influence the way we learn? Okay, and still, especially when you teach to large classes, you come to realize that some errors are common and resistant to change. So a lot of people have looked at cognitive psychology and have come up with this model for learning that has those 4 steps. Step of activation, association, compilation, and control. Activation means that new information is stored into your brain in the form of a set of linked neurons. So it's a tiny little bit of information that is stored into your brain. And the next step is associating those bits of information. Throughout this talk and in the literature, people call these little pieces of information a cognate. So associating means linking cognates together so that if I think or if I remember one piece of information, another piece of information will automatically come with it. And the large scale activation of several cognates is called compilation, so that we come up with our own mental construct of the concept or the skill that we need to learn. And eventually, by practicing often enough, we can come to the domain of control, where the knowledge actually becomes a reflex, as opposed to something that you need to actively think about to enact a skill or a new piece of knowledge. Okay, so we'll be going a little bit more in detail in explaining those concepts. So activation, thinking is dynamic, and all of our brains have little pieces of knowledge that remain dormant that we need to turn on depending on the circumstances or on the need. However, the brain is a complicated machine, and which elements are activated depend on context. So the brain needs cues in order to recall things more effectively. And this is the way our mind is wired up. So, and in the sense, memory is not recall, it's just relinking those little cognates, those little bits and pieces of knowledge together in order to remember exactly what we want to remember, what the task that we're trying to do is asking us to do. Okay, and here's some pictures from a paper that actually demonstrates this quite nicely. So here, this was a paper on cognitive psychology, where subjects were asked under an MRI scanner to remember specific things from their past. And the areas in orange and yellow show the parts of the brain that lit up under the remembering or the recall sequence. Now, the same subjects were asked to solve a problem based on what they just remembered or to think of a way to overcome a situation. And lo and behold, the same parts of the brain lit up. So this tells us that remembering uses the same parts of the brain as projecting into the future or problem solving or integrating new knowledge. So presentations that can stimulate the memory or presentations that are memorable are more likely to be integrated into one's skill sets and easier to recall for future use. So here's an example. This is a physics experiment video, and I show you, let's see if I can get the mouse to work here, a track. And on this side of the image, on the left-hand side, I have a pistol that will fire two balls simultaneously. One ball will follow a straight trajectory all the way to the end, and the other ball will start on the same track and then take a dip for a while before coming back up and then reach the same end as the first ball. So based on what you remember from your high school physics, which of the two balls do you think will come up first? The one that will go on a straight line or the one that will take a dip?
So anyone feel free to chime in on the chat over there.
And if you chime in, give me an explanation why you think you have the right answer.
So do we need to know some good physics principles to solve this one?
Not necessarily, but what you remember from your physics experience. So perhaps Sarah can be our test speaker here. Can you tell us what you think if the balls, if one of the balls would come sooner to the end, or will they come at the same time? What do you think, Sarah? Sarah thinks they will come at the same time. Why do you think that? Well, I mean, your guess is built on what you already know. So the knowledge is deep within you. Okay, so we have Dana who says that the dip will come faster because of acceleration, and Anna thinks that the two balls will come at the same time. Do we have other participants who want to chime in on this?
So my guess is the top one would come across first.
Okay, and Brian says that the straight line because the dip has a slightly longer track.
I agree with Brian. That's kind of what I would pick too.
Okay, does anyone else want to chime in? Okay, let's see what the video says. Oops. So, did you guys see that? I'll show it again. Okay. One more. Okay. So the ball that went through the dip reach the end faster? Okay. Yes, the acceleration made the ball go faster, and then the deceleration as it climbed back up slowed it down. But because it went for some time at a faster speed, it was able to reach the end faster. Okay, so here we have a panorama of people guessing what the answer was. And this was because we vaguely recall those physics principles and sometimes mixing up kinetic energy, potential energy, acceleration, deceleration. The straight path would be shorter than the path with the dip. And all of this mishmash was more or less well recalled depending on the way individuals link up that information. So individuals reconstruct memory according to what they think. And I think the responses to the video illustrated that quite well. And it also illustrates that recall is much more effective when we tie to emotionally significant, well-known cognates or bits of knowledge. They're called cues typically. And actually, it's not what you know, but how it integrates in the way your brain works that matters, the structure that matters. Here's an example, and we'll call on Sarah to help me on this because Mike did that exercise with me last week. So Sarah, I'm going to ask you to read aloud some words that I put on the screen, okay? So can you come up to a mic?
All right.
So read this aloud as fast as you can.
Haste, noise, passively, miss, go the end.
Okay. Now I'm going to rearrange the order of those words. I'm going to ask you to read them again. Ready?
Mm-hmm. Go placidly and miss the noise and haste.
So, which of the two do you think went faster?
The second one.
Why do you think it went faster?
I think it made sense.
It makes sense because the words were organized in a logical sentence, the subject, a verb, and in a way that makes sense.
Mm-hmm.
So by calling the structure of the information and placing that information in a way that our brain makes sense, made you think or do that task much faster than if it was just a jumble.
Mm-hmm.
Okay, thanks, Sarah, for your help. So, which brings us to the next bit on how we learn, compilation. So when we learn, we bring together many, many different pieces of knowledge, binding them into a single coherent unit. And here I'm showing a picture of a coffee cup. So when we dissect all the skills that we need to master in order to drink a cup of coffee, you will need to learn to tell your fingers to grasp the handle of the cup, bring it not too fast, but not too slow either to your mouth, dip it into your mouth and measure and assess the temperature with your mouth, whether you're gonna have another sip or not. There's a spoon in there as well that you may want to stir in sugar and cream. So there's a lot of little actions that when you consider each on their own, actually just drinking a cup of coffee is an incredibly complex thing. And asking robots or programming robots to reproduce those motions is incredibly difficult to do. Yet the human brain is able to do that without a thought, because as we went through childhood, we learned to apply those skills one by one and integrate them to something that becomes a reflex. So we compiled all those skills together into something that is now simple that we do in our day-to-day life. So this is the ultimate aim of the scientific presentation, to present new information and make it easy for people to integrate it into their day-to-day lives. So here's another trick, and I'm going to ask Sarah again to help me with this. So here's a checkerboard with light gray and dark gray squares. And I place here an object to create a shadow on it, okay? So I'm going to ask you, Sarah, which of the two squares is darker, square A here or square B here?
They're probably the same color.
Oh, she's seen that trick before, right? Like, I mean, typically, without saying that trick before, a lot of people would say that square B looks much clearer than square A. But if I project bands of gray, they turn out to be the exact same color.
Right.
So our brain is typically quick to claim that B should be lighter than A because there's a shadow cast from the object that makes it sort of look darker, but we know from the context, from the surrounding squares, that in our logic, it should be lighter. Okay? Thank you, Sarah. Which shows that compilation can be erroneous. Humans are notoriously bad at recalling information when there is no context. Our brain needs cues. And in that example below, the cues were the pattern of light and dark squares that we saw in the image. And this makes us jump to conclusions and misinterpret the information. So a cue might be just as simple as having students have a test or an exam in the same room that they use for learning, because the context is something that they've already assimilated into their way they think. Here's another example, Sarah. I'm going to make you work hard this time around. So here's a bunch of words that I would like you to read aloud to me.
Right now? Yeah.
Right now.
Green, orange, indigo, scarlet, white, yellow, lavender, green, cyan, dark, magenta, mustard, ochre, turquoise, violet, blue, gold, maroon, red, purple, brown.
Okay, so now I will enrich the context of the same task by making the words the same color that they are. So can you read that aloud for me, please?
Green, orange, indigo, scarlet, white, yellow, lavender, gray, cyan, dark, magenta, mustard, ochre, turquoise, violet, blue, gold, maroon, red, purple, brown.
Okay, so do you think this went faster this time around? Okay, now I'm going to remove context from you. Do the same.
Green, blue, gold, maroon, cyan, white, dark magenta, purple, gray, brown, yellow, turquoise, black, mustard, red, orange, indigo, scarlet, violet, lavender.
Okay, so these are the exact same words, but I mucked up the context a little bit, and Sarah took a while longer to read that. So this tells you a little bit how the brain works. If we enrich the context, if we make it favorable to recall things, we're better at it, no doubt about it. So, in other words, and here's a quote from Mark Twain, it's not what you don't know that hurts you. When you're faced with a new situation and you don't know what to do, you tell people that you don't know, and that's the end of it. The problem is what you know that ain't so. The misremembering, the mistakes, or what you think is actually wrong. And as we know, healthcare is a complex subject, and learning also is a complex task. There's lots of things that happen in the brain when we learn. So knowledge is a foundation, but when we apply skills, is a scientific presentation sufficient to just go from an abstract talk to a practical application? Is the time you spend during a presentation efficient and effective for the audience? So if we look back at the way we were taught physics, myself at university or in high school, the way we were taught way back when was mostly didactic lectures, as what we're doing now, where we had assignments, some talks, some written exams, and some lab reports to do. And these methodologies emphasize competence and knowledge, but not so much into performing and acting on the knowledge and making sense of the things we do in the day-to-day life. Like, don't you remember all in high school when learning something new said, what am I going to do with this piece of knowledge? Sure, you can memorize it, and after the exam, out it goes, because you never use it again. So how do we go from just learning things by rote to actually integrate it into the way we do our work? Well, unfortunately, teaching by telling or a direct lecture, just as what we're doing now, is shown to be an ineffective method of instruction for most students. And I'll show you why in a moment. In fact, there's a Cochrane study that says that continuing education events based on didactic presentation show no effect on professional practice or outcome. Sure, people like to go to Las Vegas for a course, or New York or Miami, and they have a good time, they meet some great teachers, they talk, but does the knowledge really transform the way we do things? And what the literature is starting to show is that students must be intellectually active to develop a functional understanding. And one reason why lectures aren't so efficient is attention span. Attention span is controlled by one part of the brain that focuses attention. It's called the reticular activating system, RAS. And there are 4 categories of things that trigger focus of attention in order. First is physical need. Am I too hot? Am I too cold? Is it raining on me? Is my bladder full? Second one is a self-made choice. So you self-motivated to be paying attention to what is occurring around you. The third level, that trigger of attention, is something new, a novelty. We're all curious. We're all human beings. We're all curious. The novelty of something cool is really exciting. And the fourth thing is your name. So if you're in a classroom and in a seminar and someone is snoring, if you say, Mike Velec, pay attention, Mike Velec will pay attention. But the RAS also passively filters all the incoming stimuli and decides which stimuli deserve attention to the conscious. So our brain is wired in this way. Even though we want to pay attention to a lecture or to a new piece of information, we get bombarded continually by stimuli, by sensory overload. And the RAS makes sure that we're not overloaded, but it lets some of the stimuli go through. And they come eventually to distract us and eventually cause boredom because we get distracted. So what the literature tells us is that on average, continuing attention span is about 8 seconds. Every 8 seconds, the RAS will let through a stimuli that will distract you away from paying attention. It's also demonstrated that adult learners can keep tuned in for no more than 15-20 minutes at a time. After 20 minutes, their interest wanes, it goes away, they get distracted, they get bored. It's perfectly normal, all human brains are wired that way. So as a lecture proceeds, attention span becomes shorter and often falls to 3 and 4 minutes. So here's a little bit of a graph that shows this. This shows the level of interest that people have into a lecture as a function of time. So of course, as it gets started, our interest peaks, and then the RAS lets some stimuli through, distracting us away. We lose focus and we get bored, and our interest goes down. And eventually it comes back up again, but not so much. And we lose the interest in the information that is being provided to us. Now, the trick to overcome this is to know at what time to do a technique that is called checking in. And essentially is to jig the presentation in such a way that we reestablish a peak in an interest. So every 7 minutes or so, the educators know that they need to do something to keep people interested in, either by asking a question to the audience, telling a joke, showing a graph, talking, changing topics, or changing the mode of teaching. So to maintain high attention span through a lecture, involve the participants at least every 7 minutes. And in this way, we've used this by asking you guys to type in comments on the chat room. Change the mode of instructions every 20 minutes. Tell a joke, show an image, use a quote or a sound clip. And I've already done that so far to keep you guys interested in this presentation. I hope it works. Thing is, we all learn differently. So remember at the beginning of the talk, I asked you to take a few seconds to think on one of your best learning experiences. So when learning, you prefer to watch or to do? You prefer to read or experience it? And all of our different, we will all give different answers to that. No one will be focusing on just one preferred way of learning. And that's because the brain uses several parts of the several parts of the brain that are actually intertwined when we learn. And this is a theory called experiential learning. It's been published a while back. So essentially, when we learn by active testing, we stimulate a part of the cortex, here the premotor and motor cortex, whereas the sensory and post-sensory cortex will be involved when we live through a concrete experience. If we rather want to take a step back, reflect and observe, we'll stimulate the temporal integrative cortex, whereas when we deal on the abstract ideas, will involve the frontal integrative cortex. So it would make sense when we make a presentation or when we teach that we stimulate all four parts of the brain that are involved in learning in order to increase the likelihood of retaining that new knowledge. Whereas if we only focus on one part of teaching or presenting, we are misusing or we're not making use of the other parts of the cortex that are integral to learning. So again, just to recap, we can learn by experiencing, learn by reflecting, learn by analyzing and interpreting, or learn by doing, okay? And depending on what your preferences are on those four groups, you can be classified into different types of learner. So the first type of learner is the simulator. They like reflective observation and abstract ideas and integrate this. This accounts for 33% of the population. Second group is the diverger. Consists of 25% of the population, and they like a concrete experience, but also they like to reflect on what they've just learned. So they like techniques such as group discussions, keeping a journal, brainstorming, role-playing, and debates. The third group is the converger, 17% of the population. They like active experimentation combined with abstract ideas. So they will like lab methods, practical problem solving, demonstration, and practical exercises. And the last group is the accommodator. Again, 25% of the population, and they will combine concrete experience and active experimentation. So those people will be more effective at learning using self-discovery, practicing, learn by doing, independent study, clinical experience, and interviews. So when we do a scientific presentation, we actually are using just one tool, lectures, that will please only 33% of the population, which means that 67% of the population doesn't care about lectures and will be bored. So this is why in a lecture or in a presentation, we like to use different types that will resonate with the various types of learners that are bound to be into any audience. So far in this group, sure, I've been talking, I've been lecturing, but we also had a little bit of reflection by making you guys think about your past experiences. There's been some journal keeping in the sense of the chat room. I asked you to do a little bit of self-discovery and think ahead. And again, this is a little bit of a limited format, but I haven't had the chance to integrate some converger tools to make it more experiential. But the fact is that interactive or experiential learning works. And this graph shows the performance of students who receive the same test before and after a teaching session. There were two types of teaching sessions in one in this experiment. One was just a traditional lecture, and the other was a lecture with some interactive engagement. The graph shows how the marks went up in doing the test before the teaching session and after the teaching session. And those people who had the traditional lecture did not score as well as those people who received the interactive learning. So there is proof that interactive learning and engaging your audience works and is an effective way to better make a memorable presentation. So the key to success in making a presentation is to make it memorable. Address the different learning styles. Check in by, again, telling a joke, asking a question, interacting with your audience in some way, shape, or form. Attempt to tie in emotional elements and take your audience's perspective into consideration. Put yourselves in their shoes. And a lot of the stuff that Mike will be telling us about resonates with putting yourselves in their shoes. So you've just been exposed to an interactive presentation. And again, people are more likely to learn if they can see what's in it for me. They can articulate what do I want and how will this new information integrate into what I already know. When we keep them actively engaged and the experience is intense and enjoyable, materials are adjusted to their levels and they can see results. So just to show you interactive learning, we will switch completely teaching mode by switching presenter, and we will have Mike give the second part of the presentation.
Thanks, Jean-Pierre. I wonder if anybody online has any questions. Yep. So Jean-Pierre, do you think we're kind of setting ourselves up for, failure in a way by having these conferences where really it's just lecture style?
Well, I mean, the thing is, you will rejoin, again, 33% of the population, but it's not the most effective way of making an impact, right? And we need to recognize that as a community and make room in the presentations or in the context of a symposium for other ways to learn. So having an interactive workshop right after a series on the specific topics might be a good way to do it. Mm-hmm. So this way you have hands-on practice. It's the same thing in therapy, right? Like, I mean, I see this all the time when a vendor comes in with an immobilization accessory. Mm-hmm. Sure, they show it to you, they tell you what it's all about, and then they set an actor up and the therapists come in and they manipulate the object by touching, by manipulating, and this enhances the learning, right? So, and I think big meetings like APM and Astro, to some extent, they always organize some sorts of workshops where people can discuss, exchange points of view, enrich the discussion, and enrich the learning. So it's happening. Perhaps we don't realize it so much, but there's a purpose why we do these mix-ups of interactive sessions.
I've done a few oral presentations at conferences, and I always find it unfair that they give you such few minutes to deliver your entire study. But now kind of seeing your talk, it kind of makes sense. Nobody's going to be listening after 10 minutes anyway.
There's a little bit of that.
They're already daydreaming. Right?
But also, being on the other side of things and organizing being meetings, you know that for several organizations, the meeting is a revenue generator, and you want people to come. So the more presentation and poster slots you have, the more people will come because they will want to show their work. Mm. And it's a revenue generator. So there's economics. There's the economics of organizing a big meeting that sometimes might be by accident aligned with learning.
Talks, yeah.
So, if you have a poster that you're interested in and you look at it for 20, 30 minutes, this really favors one style of learning over just hearing a presentation over 10 minutes. So you see that there's a lot of things that happen passively and sort of works with the economics of it.
So this is kind of actually happening at RTi3 too. So we have lectures and, the oral presentations. We have posters, and actually new this year, we're trying to do poster discussions too, to mix up the ways people can experience these talks. So it'll be interesting to see.
And people will speak over lunch and at the break about what they've learned and that sort of thing. So again, we don't realize it so much, but it does happen that multiple formats are hit within most conferences.
Okay, so I don't think we have any questions, so we're going to move right ahead. So Jean-Pierre kind of gave us the background of how the mind works, and this is kind of my bit now is a little bit more of the nitty-gritty and what you can do giving your next talk.
Okay, Mike, I hope you don't mind if I interject on occasion.
Oh, yes, please. Okay, so full disclosure here, this is not a scientific talk. So over the next 10 minutes, I would go in the vein of do as I say more than what I'm doing right now. So this, in a way, is more of a lecture. And there is a little bit of a difference between what you put in a lecture and a scientific presentation, for example, than what you would give at RTi3. So I have some experience doing this, and giving a good oral presentation at a conference is very challenging. You have a lot of information to convey in a short amount of time. And when I say good, or when you're successful, I really mean that the audience actually learns something about your research. And as we heard from Jean-Pierre already, I think the odds are really stacked against you. So your audience has a limited attention span. In any one sitting, I think we heard that it was 8 seconds, so you have to switch up the graphics and the text constantly. My opinion, I think nobody wants to think too hard. It should be, you should kind of facilitate the learning as much as you can. And unfortunately, we're limited by the fact that for orals, you are limited to lecture style teaching. So already, 3/4 of the audience may have a different learning style than what you're forced to use. The other thing to consider is that you have a lot of information. So you did some big study and you're trying to cram all this information into only a few minutes, often less than 10 minutes. So I think the goal to keep in mind is try and make it as easy as possible for your audience to get it.
I just want to say something. It can be very intimidating for the novice to be in front of a crowd and speak. And I would advise beginners to not think so much about that, because people who are here, they're interested to hear what you have to say. So think of the audience not as hostile, but as a bunch of friends. Okay? And one mistake to do is to look someone in the eye. This is a big no-no. At the same time, you want to have some kind of contact with the audience. So the advice that I give is to look at someone's shoulders as opposed to their eyes, because the people will say, oh, he's not making eye contact with me, but he's making eye contact with the person behind me. So you have the human contact that is so necessary in these talks. But at the same time, you don't look at someone in the eye. That would make you nervous.
Yeah, I totally agree. Sometimes I feel I go into that trap where I focus on somebody in the audience as well, and then I end up keep looking at them. And the other times I kind of do a look at the audience, but an out of focus, I don't want to say blank stare, but just looking in the direction of the audience as
Absolutely,
well.
just spanning around.
It's a connection with the audience, right?
Okay, so you connect with the audience as a whole and not as to specific individuals.
So anyway, I think the point here on this slide is, try and make it easy, and at least looking at them, giving them the idea that they're getting eye contact draws them back in, right?
Absolutely, it shows that you care. It shows that you care, and this is the emotional content that we're trying to summon into the learning.
So here's the approach I've taken that I found works really well. So like I said, you've done a lot of work, months sometimes on end, collecting data, analyzing it, reducing it down into some results, and you want to present all of that in a few minutes. And really, I don't think that's the way to go, because nobody's going to end up taking away anything if you try and present everything. So what I would suggest is to choose 1 or 3 main points that you got from your research and build your talk around them. So if you have one conclusion that you want to make sure your methods and your results tell that story for that point. You don't necessarily need to put everything in there. The other thing I think sometimes it gets forgotten, most people are good with this, is that the talk should be structured. So we're expecting when we see a talk, scientific talk, is to see an intro, purpose, methods, results, and conclusions. And I think this kind of connects to what Jean-Pierre was saying about having kind of a template so people know what to expect so that there's no surprises. And I think it's easier then to recall, probably, what was presented if you have a structure.
Exactly. So you reproduce a structure that we're all familiar with. So it helps us by providing context, how to remember better.
So sometimes this kind of breaks down a little bit when we're doing talks that aren't totally scientific based, like when we're presenting an innovation in clinic. But I think even then you could have a overview slide like we've done here to show, what's going to be expected in the talk as well. Timing. This is my first golden rule. On average, I think people should aim for one slide per minute. Now, that's on average. So, you're not going to spend a minute reading off your title, introducing yourself, but I think if you go any faster, I've done sometimes 2 slides per minute. And I think even though you can physically cram in all the information, people are going to start tuning out and they're not going to be able to recall it. Too much is a bit of an overflow. It's going to start leaking out of people's brains. In the vein of talking about time as well, exceeding the time limit is disrespectful to the people presenting after you and as well as the moderator. And in some situations, I've even seen the moderator cut somebody off and they're not even able to finish their talk. So overall, I would say go for 1 minute per slide. Now in each of those slides, aim for 5 to 7 bullets or 1 figure or table. Too much information, again, is going to, they won't know where to look. Would you agree with this in general?
I totally agree. You don't want to overwhelm and make your audience feel stupid because you throw so much information at them in such a fast way.
So starting kind of with the basics, the text here, keep it simple and keep it legible. And that's not always straightforward. So like I said, use bullet points over paragraph text. You don't even need complete, full, grammatically correct sentences. I mean, read it out loud to make sure it sounds proper, but you don't need to write a story in each slide. I think a great starting point for oral presentation is to use 24-point Arial font, all bolded. Now, when you're looking at this monitor and you're kind of filling in your slides, that's going to seem huge on the monitor. But actually, when you go into a presentation room, it doesn't seem as big as you think. In a pinch, you can use smaller font sizes, so 20 points or 18 points work. But once you start going 16 or lower, even though you can see it on the monitor in front of you, it's very hard to project that when you're in a kind of an auditorium setting.
Absolutely. When you design your slides, think of the poor guy sitting in the back row. Okay? Just think about what that person will be able to see. In fact, a guy like me, who's getting on age, my vision's getting poorer and poorer. So those small characters are getting really, really difficult to see.
Yeah, even myself, I've noticed that a lot of people don't really adhere to the, this rule of the 24-point font. So I often find myself sitting towards the front of these auditoriums now, just so I can even read the words. Okay, so the other point in the context of fonts is the actual typeface you're using. So you'll notice that, I notice now that Jean-Pierre and I have used really similar slide templates. So we're using, I believe, Arial fonts for both of ours. Mm-hmm. And those are called sans serif fonts. So if you look at this kind of text in aqua here, I have a different kind of font that I've used compared to my previous slides. And this is, an example of this is Times New Roman. And this is called a serif font.
Can you show what a serif is?
So actually, Jean-Pierre was explaining this to me the other week. So the serif is these kind of little, looking at this T in the Times New Roman, the serif is these little lines and little kind of embellishments, if you will, on the letters. That's on all of these letters. And as well, you'll notice that compared to Arial, which the other text is, they're kind of uniform in thickness everywhere in the letter. For serif fonts, the width of the letter actually varies. So I'm not sure why this is the case, but generally I think the consensus is that serif fonts are preferred for physical text. So if you're reading a newspaper or magazine, you'll by far see serif fonts like Times New Roman. But for some reason, in presentations, these don't work well.
Okay, that's because those typefaces are very aesthetically pleasing. They look good.
Up close, yeah.
Up close, okay? But again, thinking of an old guy like me sitting at the back of the row, someone with astigmatism will have a really hard time making up the different line thicknesses that the serif font has. So this is why it's friendlier and kinder to your audience to use those blocky, boring, but easy to read fonts onto a presentation.
Amanda Boulderson is chiming in. She dislikes the use of Comic Sans as well.
Yeah, and Comic Sans is right under your blue fonts, right?
Yeah, so here I put an example of something even fancier, and sometimes, I mean, you have to think about this a lot more, even when you're reading it, because the font is so different from what you're used to. So avoid fancy, keep it simple. Arial's basically, I mean, the default gold standard, I feel like. Avoid all caps. You don't want to seem like you're shouting at your audience, and it's also more difficult to read, I think. Maybe not more difficult in the sense that you can visually see it, but it's just kind of not as pleasing to the eye. Speaking of text, referencing. So I noticed Jean-Pierre did this as well, and I fully support this, is putting the reference in the slide. So sometimes we take these concepts from writing papers and we apply them to talks. So I've seen many times where people will include a references slide at the end of the talk, but you have no way of connecting the reference to where it was in the presentation. So keep the reference in the slide. So here I have two ways, I've given two options of how to reference. You can reference in line with the statement or even use footnotes. And I think both of these are acceptable. And it just keeps, you don't have to put even the full reference, I think just enough to know where to look for that reference. So at a minimum, the author name, the journal, and the year.
And give credit, very important to give credit.
Yeah, I mean, I didn't go into plagiarism, but I mean, I'm assuming people know when.
Well, I mean, it's not necessarily plagiarism, but it's also giving credit. Again, the audience is a priori friendly, and you don't want them to be annoyed at you because you didn't quote or reference someone else's work.
This is interesting. So Sarah says actually that it had to do with the old printing techniques. It sounded like serif fonts. So they started using serif fonts so that they would, I guess, bleed less on the newspapers. Interesting. I haven't heard that before. Okay, colors. Again, I mean, I think Jean-Pierre and I seem to be biased towards the black background with white and yellow text. I mean,
well, I mean, there's a reason for that, because in our field we show a lot of radiographic images.
Oh yeah,
that's the black, and it blends into the background quite aesthetically that way.
I didn't even think of the historic context, kind of, bones on a black film, right?
Yeah.
So in terms of colors, I mean, to some extent, people are going to be limited by the templates by which they're, in a way, forced to use from their institution. But in general, contrast counts here. So light on dark, very easy on the eyes. I feel like this is very good for monitors. So backlit monitors, basically what everybody's sitting in front of right now. Similarly, high contrast, dark text on light backgrounds, again, easy to read, and this projects really well in a room. Going to the top two squares here is kind of what you want to strive for. I tried not to be too dogmatic and prescribe specific colors, but I think high contrast is key here. So compared to that, low contrast is bad. So here I have an example of a gray text on a black background. Again, this doesn't look so bad on a backlit monitor, but when projected in a room, some of these words are going to become very difficult to see. Again, specifically if you're sitting at the back of the room. Some combinations are also noted to work very bad. So red on black, or even dark, like royal blue on black, is visible when projected, or it is visible when looked at on a monitor, as you can see here. But actually, when it's projected live, it's extremely difficult to read. So keep in mind, avoid red on black or even blue on black.
Again, I would advise for the novice presenter to make a PowerPoint with a whole bunch of color combinations on the background color that they choose, and then go into an auditorium, project those slides, and you will see right away what works and what doesn't work.
So of course and on the bottom right here, some color combinations are just offensive. So, pink on green, I would never recommend that. And some are actually impossible to read. So kind of when I was looking into these color combinations the other day, apparently 5% of the population, mostly men, are colorblind by some degree. So they might not even be able to read some color combinations you have. So in general, light on dark, dark on light is a safe bet here. Figures. So we've all heard the term "a picture is worth 1,000 words," and I think it's extremely true and applicable to presentations. So we don't want to use figures unnecessarily. So save them for when the information you need to convey is, first of all, important and is difficult to describe in words. So here's an example of a graph I have on the right. So here I'm comparing 3 groups. So, and here's the mean value of some arbitrary error. So think about how else I could present this. So I could present this in a table and have means, standard deviations, and p-values potentially. But then that requires some, more judgment on the part of the learner, because they're going to have to interpret what value is, or which number is higher than the other. But here in a graph, it's clearly obvious. A is a lot higher than B or C, or B or C is similar, depending on the context you want to make. If this graph was slightly different and I only had 2 groups, for example, A and B, this might not be the best use of a figure because I could potentially summarize that in a bullet point. So use figures when it's important to. And I say in the context that in the context of data as well, but also if you need to break up a text-heavy presentation. So if you had 3 or 4 slides of just text, it may be worth inserting a figure, even though it's not completely necessary.
Yeah, so that's one way to change the teaching mode and to
the 8-second rule.
Yeah, it's
Yeah, so that's a good point as well. And figures should help convey your message. So what I mean by that, I used to be guilty of that when I first started giving presentations. I put lots of pretty pictures in my presentations. So here's an example. I remember I put in an early presentation. This is a stereotactic body radiotherapy plan for the liver. And I don't even think I described this in my talk, but it looked interesting, visually, but didn't really add anything to the talk. So eye candy can be pretty, but can also be pretty useless as well. So put figures in that help build your talk, because otherwise I think they're a little bit of a distraction. If you don't have time to explain it, my recommendation is to cut it out from the talk. Now, that being said, I'm kind of a little bit biased to delivering quantitative scientific talks, but if you have a lecture where you don't have lots of data, I think it's probably a little more appropriate to put in kind of prettier pictures, or eye candy, if you will. Just as with the paper, the figures shouldn't duplicate text. Remember, you only have a limited amount of slides and minutes, so you don't want anything duplicated. So if you're writing it out in bullet points, don't put it in a figure. Figures are preferred over tables for lots of data. So I have no rule for tables, but if you're going over by a 3x3 or a 4x4 table, you should strongly consider putting it in a figure instead. Make them,
or to break it up on multiple slides.
Or to break it up on multiple slides if you have many tables. So they should also be uncluttered, plain, easily readable. All the rules for the font selection is applicable here. Remember, 1 slide per minute. So is that figure comprehensible in less than a minute, or do you need to spend more time on it? And this is another kind of golden rule, I think, that sometimes we forget to do, and I forget to do this often as well, is I strongly suggest to explain each figure to the audience. So just putting up a line plot and you're going to assume that the audience is going to understand what's happening is probably a bad idea. So spend a few seconds and walk them through it. At a minimum, for example, for graphs, explain what the axes are, explain what the main variables are, and also, if there's any obvious trend, kind of explain that. That helps your conclusion.
Yeah. So remember, the audience knows less than you do on this topic. You're the expert, and you need to digest the knowledge to them in a way that makes sense to them. So a little bit of empathy, putting yourselves in the shoes of your audience will help.
And also reinforcing, right? Visual with the audio.
Mm-hmm.
Videos I'm not going to talk about. They can be very effective, especially when showing a procedure. Jean-Pierre used a video. It definitely gets your attention. My personal experience is that videos don't work about 20% of the time, so be prepared for those things as well. But videos can show even more than a figure. I think the key here is to test it to make sure it works before you go for it.
That's a very key point. Like, before your session, show up to the podium, load your slides, project them, make sure that all your videos and images project well. Mike and I showed up for half an hour before because it's the first time we were doing a webinar. We were not familiar with the tool, so we spent some time with Sarah, who showed us how to do it. But also it made sure that I was able to show the video that I was interested in showing you guys, and that it ran on the computer. And there's only way, and even though it works on your PC at home, there is absolutely no guarantee that it will run on the PC at the conference.
Yeah, like I said, 1 in 5 times they've kind of bombed on me when I needed them. And also, you should definitely take advantage of the speaker ready room. So most conferences, you'll be able to upload your slides ahead of time and kind of be able to cycle through them just as the audience would see. So here's an example of a poor figure. So I don't know if anybody wants to chime in on the chat, or Jean-Pierre, you want to critique my figure here, but let me start by saying what I think at a minimum works in this figure. So we have the contrast, black text, white background. There's some differentiation between the 3 series here, and that's about it in terms of this figure. So this figure may have worked well in a paper where somebody has half an hour to kind of digest it, but there's lots of things that could potentially be wrong.
I'll tell you what I don't like about it, and that's not just because I'm a bad guy, but because I want you to be better. First of all, we have lots of space on the graph that's not used at all, okay? All of that space is useless and does not convey information. So perhaps adjusting the limits of your y-axis to the top will make you fill the space a little bit better, okay? The second thing I don't like about it is those little stars, okay? Some of them are really hard to see from afar, okay? And third is that even though there is some differentiation, it's a little bit of a jumble. So by stretching the y-axis, you will stretch you will help differentiate your curves a little bit better. But some people say that having a legend like this actually is a mistake. Again, you occupy space, but you know, when your eye is drawn to this line here without having an idea what it means or what the trend means, and likewise here all of a sudden I have a curve instead of a straight line. What does that mean? And again, I have a line that crisscrosses each other. What does that mean? Well, the explanation is here, okay? But for the speaker to tell, oh, this line means ITV-based PTV on XLCT, and this means this means this. You just spent a whole bunch of seconds in your slides, not very effectively.
Okay, Jean-Pierre, that's enough. That's enough criticizing. I think you got it. And Anna in the chat here also agrees. Definitely, she just summarizes it as one word: confusing. So here's kind of, I think you hit most of what I didn't like about my own graph as well. So small font, the same rules apply. The axes, I agree that they could have been optimized better. I totally agree with the legend. So legends work well in papers. In terms of a talk, I think you could do even better. Poor use of space in the graph, and also the size of the graph relative to the background slide as well. And I think this graph just kind of looks boring. It looks like it was cut and paste straight from Excel. So here's my revised version. So whether you like my, contrasting color combinations, whether these are going to match the tie I'm wearing when I'm delivering the talk, I think, given this complicated graph, I think the contrast of colors at least helps separate the different series. And I totally just got rid of the legend and just kind of color coordinated the words with each of the series as well. So I think an improvement, and it also is a lot bigger and easier to read. So in terms of some of these abbreviations, I would also, if they weren't defined before, I would define them as I'm explaining them as well. Okay, so we have a few minutes left. So you've kind of, curated your slides and your talk. What are some strategies that you can do to kind of nail it when you deliver it? I mean, one of the last golden rules I can recommend is practice, practice, practice. So you're gonna go over your slides in your head first, but then you really need to say them out loud to yourself. And then after you do them to yourself, present them ideally to your collaborators or your peers. So I think they're gonna be your biggest internal critics. So in our institution, it's fairly common practice to do a mock oral presentation in front of your lab members, for example, or your site group. And they're gonna know your research the best, and they're gonna be able to really tell you, A, if it's confusing, because they should already know what you're researching, and also they could probably challenge you the most in terms of questions. So personally, I tend to get nervous more about the questions than the actual delivery of the presentation. So presenting in-house and in a safe environment is, I think, a really great way to kind of nail the talk as well.
I would also suggest to do the talk in front of a non-expert. Okay? Reason is because if you see a glaze on their eyes, it means that you confuse the hell out of them, and that probably is a better combination of words to convey the information. That person might not be an expert, but that person is not stupid either. So it might be a good litmus test to do your talk in front of a friend, in front of a spouse, in front of your parents, or brother or sister, someone who's friendly.
Also somebody who's going to be representative of the audience, right?
Mm-hmm.
So I did put peers as well. So I specifically, aside from collaborators that know the research, somebody who's going to have the same background knowledge as the audience. So therapists, for example, that aren't necessarily involved in your specific study.
Yeah, but if you give your talk to your mom and she gets it, it means that you nailed it.
Yeah. I mean, they always say if you can explain something to your grandmother, then you really know what you're talking about, right? Not everybody has the opportunity to do this, but I've had the opportunity a few times is to watch yourself on video. So you can really learn a lot about how you deliver in terms of what you say. So likes, those kinds of annoying words that really just, take away, it takes away
bad
time.
habits.
Something I've also learned from watching myself on video is I have lots of animated hand gestures, apparently, which I don't have in normal conversation. One other thing that I've found has helped me personally as well is to memorize the first few lines of your talk. So the first slide or two, if you can really nail that and come across confident, I think you just set yourself on a really good trajectory for the rest of your talk. So I wouldn't suggest memorizing your talk in entirety.
Oh, don't do that.
Yeah, because that can come across as very robotic and stale. But even the first few lines of how you're introducing the topic really gets the ball rolling as well.
Yeah, and what if you have a memory lapse?
Exactly. Then you're
you freeze, and again, it sounds very robotic. Do not learn everything by heart.
Okay, so with that in mind, some other common pitfalls I've found for myself and I've seen in other people is too much intro, aim for one slide. What's the general idea? Too much detail in the methods and results. So go back to what I said at the beginning. Try and curate your talk to 1 to 3 main points and build the methods and results around that. Reading the slides, we already talked about this, instead of looking at the audience. I think sometimes it's also important to announce the end of your talk. So say that your last slide, in summary, in conclusion, or even say something like, now I'll take questions. So I've seen a few awkward pauses at the end of some of these talks.
Well, I mean, it's not bad to announce that you will reach your conclusion 1 or 2 slides down the road. So you guide those who are bored that their ordeal won't be interminable. I can also say, use the slides to your advantage. Like, I mean, each of the bullets here is a cue that Mike exploited to really illustrate the point that he wants to make across. So think of your slides as your cue cards, because you know that stuff. It's just spitting it out at the right moment.
I think you said the right thing too. Cue cards and not script either. Don't just read what's on the slide, but use it as a reminder of each of the points you want to make. The other thing I do better now that I didn't do when I first started doing talks is anticipating typical questions. So you know your research better than anybody. You should know where the holes are, or I hope you would know most of where the holes are. Have good responses, or the best response you can, kind of lined up already. And especially when you're curtailing the talk and curating it, you're going to purposely leave out some things that you know people are going to ask about. So have responses for those ahead of time. So to kind of summarize this, if I could put it in 5 bullets, reduce the content of your research based on 1 to 3 messages you really want to get across. Spend a lot of time optimizing the text, especially the figures and even the colors, and strive to make it as easily understandable as possible. So do your audience a favor and help them understand it. Aim for 1 slide a minute. I think that's a good rule. Practice out loud to yourself, practice out loud to your colleagues, and even, like I suggested, practice the question and answer period, because it seems like a lot of people are also nervous about that. So with that, that's all I have for this. If anybody has any questions from the audience, Jean-Pierre, if you have any questions or thoughts?
No, I think I don't have questions. I hope we're going to get a few questions, though.
So what would you suggest somebody that's nervous about questions?
Oh, boy. I used to be really, really nervous in university when I was a novice speaker for 2 reasons. A, stage fright, and B, I was speaking my second language. And that was really challenging. And having, realizing that the audience is not out to get you, that's a big plus. Practice, practice, practice also makes you feel more comfortable delivering the message. Make sure you time yourself. And for me, I guess from personal experience, even though I was nervous going on stage, I really like going to theater and watch plays. And one day I realized that, hey, when I give a talk, I'm an actor on stage. I'm doing the thing that I love so much, that I love to watch so well. So just that thing flipped into my mind and made me really comfortable being on stage. So I suppose every individual has their own story as to how they become comfortable about it. This is mine. You might have a different one, Mike.
So one thing I noticed when I first started giving talks and answering questions is sometimes I would jump to the answer, I don't know, when in fact I did know. So that's kind of going back to what I was saying about having some answers in the bag already. So you deliver those, because I feel like I just kind of blew off the question and said, I don't know. But when I thought about it, I'm like, that was a very legitimate question, and I had a really good answer for it.
Yeah. Well, I mean, I also give that piece of advice to novice people. It's okay to take a pause and collect your thoughts before you answer. Don't take a pause that takes forever because it makes you look ignorant. But if the ideas don't come up, say, I don't know for now, but maybe if we chat offline, we can sort it out.
Repeating the question is also a good strategy to buy you a few seconds, right?
Absolutely. And again, maybe the question will be clarified.
So Ruth has a question. How do you handle questions from your audience that's completely out of the scope of the presentation? So I'll answer first. I think if you can answer it and it's not related to the presentation, go for it if you're confident about it. If it's not related and you're not sure, I would point that out and say that this isn't directly related to the talk I just gave. However, this is what I think. I don't know how else you would handle that. I think it's
good advice, but also it's the job of the moderator to catch those sniper-like questions. Okay, so just like the moderator can cut a speaker short, and I profusely thank Sarah for not cutting this talk short because we're already 10 minutes over. It's also the job of the moderator to act in case some misbehaving is happening.
Yeah.
Okay.
I mean, I'm assuming this isn't like a malicious question, but it's kind of a little bit of a maybe a big tangent from where.
Well, I mean, the thing is, it's so upsetting to have a question that has no bearing or little bearing to what you're talking about. You're emotionally upset whether you like it or not. So the moderator should also be empowered to catch these situations and say, look, can we discuss this offline at the break, or that sort of thing. Okay.
Okay, I think we have time for one last question from Amanda. She wants to know if there's any suggestions to get some audience interaction without putting people on the spot.
Well, I mean, show of hands. You can say, do you guys prefer to learn by learning or by, do you guys prefer to learn by listening or by reading? So show of hand, who likes reading? Show of hands. You also have several meetings will have clickers that will be distributed to the audience that will give an opportunity to answer multiple choice question and to show interactively the results on a graph that's easy to interpret. And actually, this is good because as a speaker, it takes minutes away from you if you're a nervous speaker. So you have to do less work, and you have the audience to do more work for you.
Yeah, I would say I used to kind of like when I didn't get questions, like, you know, I'm like, whew, I got by scot-free. But now I'm kind of, I always wonder when I don't get any questions, did I really give a good talk, right?
Yeah.
And in those cases when I don't get any questions, actually I do the same thing. I ask the audience a question, kind of just a raise of hands. Is anybody using XYZ technology that I presented?
Okay, there's another question from Danitra. Any tips for if a joke does not go well or with the audience or your slides freeze? So the first one, I strongly advise against using humor in jokes if you're a novice speaker. Do not use humor because what I find funny, Mike may not find funny. What if the audience with your slides freeze? Then by that, I suppose you mean a technology, a bump or something like that. Then the problem is it's completely outside of your control. So you can ask the audiovisual guy to help. Sometimes the audiovisual guy is a student who doesn't know much besides hitting the big green button on and off. Sometimes they're more helpful. Use them to your best advantage, but don't let them use too much of your time because this is your time to shine. So I hope this catastrophe does not happen to you.
I think it actually happens commonly, usually not for too long, but sometimes there'll be a glitch in slides or transitioning between speakers. I think the most important thing is to not lose your cool.
Yeah.
So just acknowledge that the slides are frozen, and you can even say, you know, can I get some technical help over here? I think it's okay if there is dead air for a little bit. It's not your fault, and you don't need to come in with some jokes or anything like that.
And likewise, this stresses the point of showing up to the podium before 10, 15 minutes before the session starts and show your slides on the screen and make sure that everything runs well as you practice, because then there's a good chance that it will also run well during the presentation.
Okay, well, thanks everyone for joining us. I know we went a little bit over time to keep the discussion going, but I believe this is going to be uploaded to YouTube, so people can, if they couldn't stay for the whole thing, they can watch the remainder after.
See you, everyone.